everyone, I am Dr. A. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to have a discussion on Reciprocity Theorem and its related problems. So first, in the Reciprocity Theorem. So Reciprocity Theorem in a linear bilateral network, when we interchange the source terminal and branch terminal, that means excitation and response is, when we interchange the response and excitation, the ratio of response to the excitation is same. So if you see here, so this is the circuit. It is a linear bilateral network. It can be applicable only for linear bilateral network, and it can be applicable only for single source network, not for multi-source network. And here in a linear bilateral network, this is the source terminal, that means excitation terminal A and B, and this is C and D. And here A, B, C and D. Here AB terminal and CD terminals are interchanged. So source and excitation are interchanged. Here CD, this response is the current. Here excitation is the voltage. Same way here, change the source terminal, that means voltage source is at CD terminal and current source is at AB terminal. Now here this current is changed. So now the ratio of response to the excitation, or excitation, here excitation is the voltage and current. Here for circuit 1, this is the circuit 2. Circuit 1 excitation is the voltage, and circuit 2 circuit 1 response is the current. So this is the response of circuit 1, this is the excitation of circuit 1, V by I, and response of circuit 2 is the I dash, and response of excitation of circuit is the V dash. Now the ratio of excitation to the response is same, otherwise response to the excitation is same when we change the positions of response and interchange. If you see the definition statement, in a linear network, in a linear bilateral single source network, these 3 points are important. Reciprocity theorem can be applicable only for single source network. If two sources are present, we cannot apply reciprocity theorem. And if we have current source also, we can apply reciprocity. Only current source we can apply, only voltage source we can apply, but only multi-source network we cannot apply reciprocity theorem. In that, the ratio of excitation to the response remains same when the positions of excitation and response are interchanged. So positions are interchanged, then the ratio of response to the excitation is same, or response to the excitation is same. We can use this one. Now while applying reciprocity, while calculating the response, we have to follow total 3 steps. So first, determine the branches between which reciprocity is to be established. So that here A and B and here C and D are branches in this reciprocity to be established. And second one, the current in which when excitation and responses are not interchanged. Here circuit 1 indicates responses and excitations are not interchanged. In that case, determine first current. And second case, when this response and excitation are interchanged. So at that case, determine current. So now after getting current, now verify the reciprocity theorem. Now let us take one problem first. Here, for a given network below, verify the reciprocity theorem. Here this is the circuit, 20 ohms, 5 ohms, 10 ohms and 4 ohms and 6 ohms. So verify the reciprocity theorem. This is the I. This is the excitation. This is the voltage. So I by V or V by E equals to. Now this is A terminal, and this is B terminal, and this is A, this is C, and this is D. Now interchange this is circuit 1. Circuit 1. Now here circuit 2, this is A, this is B, and this is current I, and this is A, C, and this is D. Now interchange the branch terminal and source terminal, means response terminal and uh, excitation terminal, and find out the response. Now here in the first circuit, response this current, this is the I1 current and this is the I2 current. I1 and I2 are same. I2 current, if you calculate the I2 current, then we can obtain the I response current I. Now for this, apply mesh analysis. In the mesh analysis, first step, apply KVL in the mesh 1. 20 is the rising voltage and minus 5 drop voltage, resistive drop, minus 5 I1. This one 5 into I1 and 10 into I1 minus I2, that equals to 0. Next, if you simplify this one, that equation is 15 I1 minus 10 I2 equals to 20. This is the equation number 1. Now second mesh equation, here minus 4 into all our resistors, resistive drop, minus 4 I2 and minus 6 I2 and minus 10 I2 minus I1. This is second equation. Now simplify this equation. Modified equation is minus 10 I1 and 10 plus 4 plus 6, that is 20 I2 equals to 0. Equation number 1 and equation number 2. If you solve these two equations, you will get I1 and I2. Here I1 equals to 2 and I2 equals to 1. Now here the response current is the I. This is the I. Response current is the I, that is the 1 amp. Now the ratio of response to the excitation or excitation to the response, first calculate. So 1 and 20. So keep it aside. Next, second circuit, this is a circuit 2. This is circuit 1. Circuit 2, apply KVL. When we interchange the source terminal and branch terminal, so this source, excitation and responses are interchanged at these two terminals. So here plus 20 and this 20 and this is the current. So response and excitation are interchanged here. Now here C and D and B. Now here if you apply KVL, I1 and I2. Here the response current is the I1 minus I1. This is in downwards direction. This is in upward direction. Downwards and upwards. So I response current equals to I equals to minus of I1. Now if you apply KVL in the mesh 1. Now here for this case, minus 5 I1 minus 10 I2. I1 minus I2 minus 5 to only 2 resistor. There is no voltage source here. There is no voltage source here means only dropping voltage 5 into I1, that is minus, and minus 10 I1 minus I2 equals to 0. In the second mesh, if you simplify this one, 15 I1 minus 10 I1 minus I2. This one minus 10 I1 minus I2. Now here second equation, this is minus 10 I2. Don't, this is wrong. So minus 10 I2. Next, second equation, 4 into I2 and minus 6 into I2. This is minus, and minus 10 into I2 minus I1. This is minus 20 equals to 0. Now here minus 10 I1 plus 20 I2 is equals to minus 20. So this is the equation number 1 and this is the equation number 2. If you solve these two equations, you will get, so I1 equals to minus 1 and I2 equals to minus 1.5. Now here there is a response, I1 equals to minus of I1. So I1 equals to minus of I equals to minus of minus 1, that equals to 1. Now here in the first circuit response is 1 ampere and in the second circuit the response is 1 ampere. Now V by I equals to V dash. This is a V dash and this is a I dash. and V dash by I dash is same. This is 20 by I, that is 1 amp, and that equals to, this is the 20 and this is the 1 amp. Same current. The ratio of response to the excitation is same. Now if you take here 5 volts, if you take here 5 volts, here the ratio should be, this should be, and this should be 5, and this should be, it should be 20. 20 means, so 1 by 5 it should be. The current should be 1 by 4. So 0.25. If it is 10, this should be 1 by 2, 0.5. So the ratio of response to the excitation is same. It remains same when we interchange the positions of excitation terminal and response terminal. This is the circuit 1. This is the response of this one, that, but it is minus. This is in downwards and it is upward, that is minus. Now second problem, verify the reciprocity theorem for a given network below. Now here this is a circuit 1 and this is a circuit 2. Now here the response is I and here the response is I dash. Circuit 1 and this is the circuit 2. This is a V dash and this is the V. Now here V by I equals to V by I dash. It should be verified. Then only reciprocity theorem will be verified. It can be applicable only for single source network. Here the source is 10 volts and the response is, excitation is 10 volts and the response we need to calculate, that is I, and this is A and this is B, this is C and this is D, this is A, B, C, D. Now interchange the excitation terminal and excitation position and response position. Then calculate the response of circuit 1 and circuit 2. Now the for circuit 1, 10 into minus 1000. 10 is the rising voltage minus 1000 I1 minus 2000 I1 minus I2 is equals to 0. This is equation number 1. Now if you simplify this one, 3200 I1 minus 2200 I2 equals to 10. Equation number 1. Now second mesh equation. So minus 2200 I2 minus I1, this one, and this is I1. This is I2. Now minus 3300 I2. Now here, so the simplified equation, minus 2200 I1 plus 5500 I2 is equals to 0. This is equation number 2. Now if you solve this equation number 1 and equation number 2, you will get I1 equals to 0.004310 and I2 equals to 0.001724. Now solve this two. Now these are the, now here is the I2 is the response current. Now this current, I2 current is the, that equals to 0.001724 is the response current. Here this is the 10 and this one is the 0.001724. And now here second, this is the 10 and you need to calculate the I dash current. So how you will calculate this I dash current? I1, this is I2, these two are mesh currents. I1 2 meshes 1 and 2. Mesh 1 current is I1 in clockwise direction and mesh 2 current is in clockwise direction. If you apply KVL in this, so 1000, this 1000 I1 and 2200 I1 minus I2, this is minus, it should be minus. Now if you simplify this one, 3200 I1 minus 2200 I2. Now this is equation number 1 for this particular circuit if you apply KVL in the mesh 1. Now in the second mesh, if you apply KVL, so 2200, that is minus, that is dropping voltage, resistive drop, 2200 I2 minus I1, and 3300 that is I2 minus, this is also drop, and this is the rising voltage, but it is flowing, current is flowing from plus to minus, so it is a minus and it is 0. Now here minus 2200 I1 plus 5500 I2, that equals to minus 10. Equation number 2. Solve these two equations, equation number 1 and equation number 2. If you solve that one, you will get I1 current is 0.001724 and I2 current is minus 0.002507. Now here this current is a response current, that is minus. This is upward current and this is downward current. So that current response current is 0. Minus of minus 0.001724. This one. Now here the responses are same, excitation is same, but responses also same. The ratio is all automatically same. The ratio of response to the excitation or excitation to the response remains same when positions of excitation and responses are interchanged. That is the reciprocity theorem statement. So according to that statement, for this particular network, so the theorem is verified. Now the third problem in this reciprocity theorem, for a given network, below verify the reciprocity theorem. Here we have 3 loops. So for this particular 3 loops, verify the reciprocity theorem. Now here this is A and this is B and this is C and this is D. And here only we have single source network, then we can apply superposition theorem. It is a voltage source. So now change the positions of the excitation and response. Here verify I, and this is the excitation V. So V by I must be same for if you interchange the. So now here this is A and B, this is the downwards I and this is A and B. Change the positions of excitation and response here. So 10 volts and response is changed. This is I dash and this is the V dash. V by I must be equals to V dash by I dash. It should be verified. Or I by V equals to I dash by V dash. You can use any one. So first, if you apply KVL in the first mesh of network 1, circuit 1, this is circuit 1 and this is circuit 2. Circuit 1 means when positions of response and excitations are not interchanged, and circuit 2 is positions of response and excitations are interchanged. So in the first mesh, in this I1, in this I2 and this I3. Now here for this, so 10 into 10 is the rising voltage, 10 volts, and 10 into I1 and 47 into I1 minus I2 equals to 0. This is equation number 1. If you simplify this one, 57, 10 plus 47 is a 57 I1 minus 47 I2, and there is no I3 impact on this mesh, and that is 0 I3, that equals to 10. That is equation number 1. Now here 47, second, if you apply KVL in the second mesh, so minus 47 I2 minus I1 and 200 to 220 I2 minus and 150 I2 minus I3. Now he equals to 0. Algebraic sum of total voltages in a loop equals to 0 according to the KVL. So all resistive drops summation must be 0. Now simplify this one for minus 47 I1 and minus 150 I3 and plus 47 plus 200 220 plus 150 equals to 317 I2. This is equation number 2. Now third mesh. In the third mesh, if you apply KVL means algebraic sum of resistive drops must be, all voltages must be 0. Here we have only 2 elements. This 2 elements voltage must be same, that 150 I3 minus I1. If you apply minus 150 I3 minus I1 minus 10 I3 equals to 0. Algebraic sum of total voltages in a loop equals to 0 according to the old KVL. Now the simplified equation 0 I1, there is no impact on third mesh, that I1 impact. So 0 I1 minus 150 I2 plus 150 plus 10 I3. So this is equation number 3. 1, 2, 3. If you solve these 3 equations, I1 equals to 0.190, I2 equals to 0.019, and I3 equals to 0.018. Now here the response current is the I3 current. So this is the I3 current is the response current that equals to 0.018. Here this is the 10 volt. V excitation is the 10 volts and response is the 0.018. Here we need only I3 current because I3 current is a response current. Now here for the second circuit, if you apply KVL, if you apply mesh analysis, then if you use mesh analysis, then you can calculate the current flow, that response current I dash for the circuit 2. Now here if you apply KVL in the mesh 1, 2, 3, mesh 1 current I1 and mesh 2 current I2 and mesh 3 current I3. This I1 current and I dash current is same but opposite direction. This is in downwards and this is upwards. Top to bottom is I1 and bottom to top is the I dash is the top to bottom and I1 is the bottom to top. So now here if you apply KVL, so algebraic sum of total voltages in a loop equals to 0 at any instant of time. So 10 into I1 minus 10 into I1, 47, I1 minus I2 equals to 0. This is equation number 1. If you simplify that one, 57 I1 minus 47 I1 I2 and there is no impact of I3, that is 0 and equals to 0, equation number 1. That is next 47 I2 minus I1 and 220 I2 and 150 I2 minus I1. So all are minus, so resistive drops you can take positive also. Now simplified equation, 47 I1 and 150 I3, same thing, this one, and 317, same thing, this one, there is no change in this. So equation number 2 is for minus 47 I1 plus 317 I2 minus 150 I3 equals to 0. Now minus 150 I3 minus I2 and minus 10 I3, this one and this one, and this is minus 10. Current is flowing from plus to minus. This is plus and this is minus. That equals to 0. 0 I1. So there is no impact on mesh 3. So 0 I1 minus 150 I2 and plus 160 I3 equals to minus 10. So equation number 1, 2, 3. If you solve these three equations, you will get. So this is the 0.018 and this 0.022 and this one is a 0. This current and this current is same. So this current equals to 10 by 0.018. So the ratio of excitation to the response remains same when positions of the response and excitations are interchanged. So now the reciprocity theorem is verified. Now fourth problem, for a given network below, verify the reciprocity theorem. Now here this is the circuit. So here we have only one voltage source, then we can apply the reciprocity theorem. It can be applicable only for reciprocity theorem. Now the response here, this one, I dash I. Now here if you change, this is A and this is B. Now here this is A and this is B, this is the I dash and this is C and this is D. Now ratio of response to the excitation is same. So now positions. So this position and this position must be interchanged. When we change the, here excitation V and the response is I, and here excitation is V dash and here excitation is I dash. So V by I equals to V dash by I dash must be same according to the reciprocity theorem statement. Now if you apply KVL only, then we can calculate the I. This is the I1, this is the I1 and this is the I2 and this is the I3. Here this is the I1, here this is the I2 and this is the I3. I1, I2 and I3 are the mesh currents in clockwise direction for circuit 1 and circuit 2. Now here, if you apply KVL in the mesh 1, here I3 current is this circuit 1 response, here I1 current is minus I1 current is the circuit 2 response current, that is I dash. So 5 into minus 2 I1, this 5 equals to, this is rising voltage, and 2 into minus 2 I1 plus 3 into I1 minus I2 and 4 into I1 minus I3. So this is the equation number 1. And next, 9 into I1 minus 3 I2 minus 4 I3. So 2 into, not this one. If you simplify this one, so 9 into 2 plus 3 plus 4, that is 9, and minus 3 I2 and minus 4 I3 equals to 5. Now if you apply KVL in the second mesh, so 2 into I2, that is minus, and 3 into I2, that is minus, and 3 into I2 minus I1. This one, 2 into I2 minus I1. Now this one, minus 3 I1, this one, plus 8 I2 equals to 0. There is no element here, there is no I3 term. Now here, minus 4 I3 minus I1, this one, and minus 4 I3 equals to 0. Simplify this equation, minus 4 I1 minus 0 I2 plus 8 I3. Now 0.085, 0.32 and 0.43 are I1, I2 and I3 currents respectively. Here I3 current is the response current, this is the I. This is 5 and this is the 0.043. Now calculate the response current for circuit 2. Circuit 2 I dash is the response current. If you calculate the I1, I2 and I3, in that I1 is the response current, that is in opposite side. So minus 2 I1, same thing, but there is no voltage source. Minus 2 I1, minus 3 I1 minus I2 and minus 4 I1 minus I3 is equals to 0. And the simplified equation, same thing, but there is no 5. 9 I1, same thing. This one, this must be same, this will be same. 9 I1 minus 3 I2 minus 4 I3, minus 2 I2 minus 3 I2 minus I3 minus 3 I2, this one same thing. So this one is same, but this should be I1. Now here the simplified equation, minus 3 I1 plus 8 I2 equals to 0, that is equation number 1. This is equation number 2. Same thing, but third mesh equation, 4 into I1, I3 minus I1 and 4 into I3, and this is current is flowing from minus to plus, that is plus. And if you simplify this one, minus 4 I1 minus 0 I2 plus 8 I3. Now solve this equation number 1, 2, 3. So if you solve these 3 equations, you will get I1, I2 and I3. Here this is the I1 current, 0.043. This is the same 5 volts and this one is the 0.043. So now ratio of response to the excitation is same for both circuit 1 and circuit 2. Now the reciprocity theorem is verified because the positions, even we interchange the positions of excitation and response are interchange, if we interchange, and the ratio of response to the excitation to the response remains same here. Now next problem. For a given network below, verify the reciprocity theorem. Now here the current source is given 10 amps, 4, 2, 5, 6 and 2. 6 and 8, this is the 5. Now here current source is given. If current reciprocity theorem can be applicable for single source network. That source may be a current source or voltage source. In the last 4 problems, voltage source problem we discussed. Here this is a a different case, that is current source is given. If current source is given, the response is the voltage is the response. In the previous case, voltage source is the excitation and the response is the current. But here the response is the voltage here 5 volts. Verify the reciprocity theorem across 5 ohms. Here the excitation is the excitation is the 10 amp and the response is the voltage. And if you change this one, here the excitation, this is the response and this is the excitation. 10 amps is the excitation. Now here the ratio of V by, here this is the excitation, here V by I, this V by I, this is the I, V by I. Here V is the response. Don't confuse. In the previous problem, response is the current and excitation is the voltage. But here a current source is given, the excitation is the current and response is the voltage. Now here also I dash, this is the I dash and this is the V dash. This is V dash and I dash by V dash. Now this is V dash by I dash. So this ratio must be same when we change the positions of response to the excitation are interchanged. Now here this for 10 amps and 5 ohms are connected in parallel. So using source transformation technique, so current source in parallel with resistance, it can be replaced any terminal by voltage source in series with resistance. That voltage source equals to V is equal to IR. So 10 into 5 equals to 50 ohms. Now this circuit and this circuit is same if we use the source transformation technique. Now here for this circuit, the excitation is the current, that is I, this is 10 and this we need to determine. And here in this case, same, the excitation is 10 amps, so that is 10 amp and the response current, the response is V dash, we need to determine. So first if you apply KVL in the circuit 1, so I1 equals to 10, this is the I1, same current. So 10 current source current is the I1 current, this is the I1, this is I2 and this is the I3. Same, I1 current is 10, that current source, same current source current is the loop current, mesh current is the I1. So that is equation number 1. And if you apply KVL in this second mesh, so 4 into I2 minus I1 and 2 into I2 and 5 into I2 minus I3. All are minus, all are resistive drops. And that equals to 0 algebra if you apply KVL in the second mesh. And next, if you simplify that one, 4 minus 4 I1 and minus 5 I3 and 4 plus 2 plus 5, that is 11. Equation number 2. That is equation number 1 is I1 equals to 10 and equation 2 is minus 4 I1 plus 11 I2 minus 5 I3 equals to 0. Now here minus 6 I3 minus I1 minus 5 I3 minus I2 and minus 8 I3 equals to 0. Now here simplified equation minus 6 I1 minus I5 I2 plus 19 I3 equals to 0. Equation number 1, 2, 3. If you solve this 5 I1 equals to, this I1 equals to 10 as it is this one and I2 equals to 5.76 amperes and Phi3 equals to 4.67. So these are mesh currents. So from the mesh currents we can determine the branch currents and branch voltages each resistor. Here we need voltage value, voltage across 5 ohms. So this voltage across 5 ohms equals to V 5 ohms equals to, that is V equals to 5 into I1 minus I2 or I2 minus I1. So sorry, I2 minus I1. So here I2 we have the value 5.76 and I3 4.67 and this is 5 resistance. So if you substitute in this, you will get V equals to 5.45. Now we got the response and excitation for circuit 1. Response is here voltage that equals to 5.45 volts and the excitation is the 10 volts. This is 10, sorry, this is 10 and this is a 5.45. Now for this circuit and this circuit is same. So first calculate. If you can calculate the response of voltage for this circuit, but if you use this circuit, the circuit complexity is increases. First simplify that this circuit into only single branch, then we can apply KVL for each mesh. So using network reduction technique, that means source transformation technique, then we can simplify. Current source in parallel with resistance is replaced by voltage source in series with resistance. Now for this circuit, the response is here. So V, this is I1, this is I2 and this is I3. Now here V minus 4, I1 minus I2, 6, I1 minus I3 equals to 0. Now here minus 10. If you simplify this one, so 4 plus 6, my 10 minus 4 I2 and minus 6 I3 equals to V. Now here second mesh equation, 2 into I2 minus 2 into I2, 5 into I2 minus I3 and 4 into I2 minus equation. This is equation number 2. This is equation number 1. The simplified equation number of equation number 2 minus 4I1 plus 11 I2 plus minus 5 I3 is equal to 50. Now here third mesh equation in this now here 5 into I3 minus I2 and 8 into I3 and 6 into I3 minus I1. Now that equation minus 6 I1 and next minus 5 I2 plus 19 I3 equals to minus 50. That equals to equation number. If you solve these three equations, you will get I1, I2 and I3. So here I1, I2 and I3. So here we need this response voltage. This is 5.42, almost same, this one and this one. Now here the ratio of response to the excitation, this is the excitation and this is 5.45 and this is 10 and this is 5.42. Now here the ratio of response to the excitation is same when we interchange the source terminal and branch terminal. That means excitation and response terminals means the ratio of excitation to the response remains same. So now we solved total 5 problems. If you still have any doubts, you can comment in the comment section below. I will answer to your queries. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.